to the power 8 meter per second. Hello guys, I'm gonna eat banana. Oh my gosh, rich in potassium, magnesium. Charot. Do you wanna eat banana and after that we'll solve problems? Okay. Well, eating banana, I need to write a problem, right? To save my time. Okay. A positive charot charge of 50 microcoulomb, wow, is placed in electric field. Is placed in electric field. In electric field. Then, okay, of 50,000 Newton per coulomb, the unit of electric field, right? Directed upward. Directed, okay, upward, right? Ganon. Okay. What mass should the charge has remained suspended in air? What mass? Okay. Asking for the mass. Should the charge, okay, should the charge, okay, have remained suspended in air? Suspended in air. The tricky part here, guys, is the air here. But the air here is telling only that it's freely, freely placed only. There's no such, tension like that. Okay? There's no tension force. There's no fractional force. Ganon. Okay? This only, it's just like a decoration in this problem. Emphasizing only that it is freely placed. Okay? You get the point? Not under tension or not under stress. Okay? Ganon. So, positive charge. Okay? Sabi na siya. So, you need to illustrate, right? For example, this one. So, this is our material. Okay? So, is placement siya in an electric field. Ganon. Okay, here. Ta-da-da. So, like this. Okay. So, we have here the positive charge. Positive, 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 positive. Because, see? Positive charge. And the purpose only for equality, for the law of third law of Isaac Newton. Remember the third law of interaction. In every interaction, there must have equal and opposite reaction, like that. Get the point? This third law, right? Or the law of free fall or free falling body, something like that. Third laws of motion. Okay, and then we have the negative here, so that we need to have the opposite. Okay, like that. So if we have a positive here, okay, like it will do the chuba chuchu, okay, your electric field will be directed away, like this. This is your electric field, okay. And then if it is a positive charge, your force also will go in the same direction. So your force will be going there. Tadadat force. Tadadat force. Okay? Now if you try to do a separate illustration. So we have the positive charge here, like this. So meaning to say your electric field will go outward like this. Okay, this is your electric field, electric field, electric field, electric field, electric field. Now if it is a negative charge, so your electric field will be going towards the negative charge here, the object, something like this. Electric field, electric field, electric field, electric field, electric field. Now, we need to focus on the first scenario because the problem is stating positive charge. It's not stating the negative charge. So go directly to this positive charge because you will waste your time. The question is asking only for the positive charge, right? Now let's say we will connect this to this material into a galvanic or a voltaic cell. Okay, there's a positive and negative. The terminal, you should be careful with the terminal, huh? Okay, the cathode and the anode, because you know the positive will be negative material and the negative terminal will be the positive, so that it will be reacting with each other. That's the point. Take the same, then it will repel. Okay, something like that. So, what is the formula of electric field? Electric field is equal to the electric force is equals to Q. Ganon. Okay? Now, this is upward, going upward, so we are also going downward. So, this is under the influence of vertical motion. Again, from the law of Isaac Newton with regards to force, we have force, gravitational force. There's also gravity in this because it's an object going downward. Anything that will go downward, go up, go down, have always gravitational force directed to the Earth's surface. No excuse. Okay, all materials that will be dropping, all materials that will be falling, it has a corresponding weight force, its mass, and the gravitational field strength. Okay, or the gravity, something like that. So that's why we have gravitational force of this material, negative charge and positive, will equal to the mass times the gravitational field strength G. Okay. As I told you, as I discussed a while ago, yesterday, the gravitational field strength will always be equal to the acceleration due to gravity. Because as it goes down, it will accelerate. So, accelerate in the sense that it will be fast moving downwards. So, we need to say you have a negative acceleration. So, technically, deceleration. Okay? Because acceleration is a general term, whether it will be decelerating or it will become accelerating. Because that's all acceleration, one negative and positive acceleration. Negative acceleration is decelerating or deceleration. Since downward siya, so deceleration. Okay? Or decelerating. Now, you have the influence of the gravity. So this is the equation to be used. Equation 1 and equation 2. Now, take note the common. So we have the forces. Okay, now, since this is very common, so substitute the force in the numerator here because this is related to the topic of electromagnetic force or electric force. So, E, electric field, is equal to the mass times the gravity times the Q. Okay, this is your equation 3. Now, take note, you are asking for the mass. So, we need to solve the mass. So, crisscross technique in algebra. It's gonna be mass times gravitational field strength is equal to the electric field times the charge. Therefore, mass is equal to the electric field times the charge times the gravitational field strength G. Now, we have now the mass. So, take a look back again to your problem. If these quantities are already mentioned here. Electric field is mentioned there. Yes, it's mentioned. 50,000 Okay, Newton per coulomb. Okay. Your charge is mentioned? Yes. 50 microcoulomb. What's micro in prefixes in math? That is times 10 to the negative 6. Okay, then after that, nano. Okay, and after that, pico. Like that, okay? So, it's gonna be like that because it's not. We have also the positive prefixes like mga giga, mega, blah, 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 so and so. Okay, but here, this is a negative prefix in math, which is micro, raised to the power negative 6. Okay, so you will say 50 times 10 exponential to the negative 6 coulomb. Okay, and then over the gravitational field strength. Do you have the gravitational field strength? Yes, because that is standard. That is 9.81 Newton per kilogram. So na naki-kilogram, i-determine ito, so pasok sa banga. That will be your unit for the mass. So use the calculator. Okay. So that is your mass needed. Okay. So is equal to, so it's easy to detect because the problem will really say electric field, magnetic field. So okay, way lubog. Okay. So we have 50,000 times 50 exponent to the negative 6 is equals to divided by 9.81 is equals to, we have 0.254 coulomb. 0.255 coulomb. Okay? No, not coulomb. This is mass, kilogram. Sorry. 0.255 kilogram. Answer. Sorry, this kilogram here. The mass man siya. Okay, tao lang po. Charot. Okay, ganon. 0.255 kilogram. Okay, right? So, muna siya natabo karon, pasok sa banga. Okay. Diba? Okay, mga palangga. So, that's it for the first example. I'll be going back to the second example. Okay, I will rest for a while and doing coffee for life. What's the time now? Coffee for life daw. Sabi ni Jun. Thank you so much for watching. I hope you like our first example and you can also practice solving because math is really practice makes perfect. Something like that, okay? So that you can encounter a lot of variations, styles of the problems you will be encountering, okay? Like that. So, because you cannot expect also that in an actual examination, it will be the same as what you studied as long as you maximize your study regarding the how to solve, okay? At least, di ba? Okay. Ganun siya. Thank you so much, guys. And if you want to subscribe to my channel, you can subscribe and you can also click notification bell for service after the singer channels. Remember, Jesus loves you or Jesus loves us. Thank you so much. I'll be back later.